Hello, today we're going to cover Business Calculus, section 1.3. A really big concept in calculus is the idea of slope. So just a refresher of slope, remember that it was the rise over run, which means that it was the change in the y values over the change in the x values. Now, it didn't really matter which point you started with as long as you were consistent. So it didn't have to be the left or the right. It was just that whichever point you pick, that y value needs to match up with that x value. So if I were to find the rate of change of these miles over hours, I just need to find the change in the y values over the change in the x values. So this one goes, one second. So this graph goes from a y value of 0 to a y value of 105. So 105 minus 0. And the x value goes from 0 to 6 over 6 minus 0. So really just 105 divided by 6, which is, of course, 17.5. And that would be the miles per hour difference. The miles divided by the hours. This one, it goes in feet per second from 0 to 3,600, from 30 to 0, or 0 to 30, sorry. So if I took those and divided out that ratio, then I would get that this was 120 feet for each one of those seconds, feet per second. So it's just the rate of change of the y values divided by the x values. So this formula was in play during these, but sometimes you can kind of reason through it. Now, if I were given a slope like this with kind of weird values, remember that it's still the same idea, the change in y's over the change in x's. So if I took the y value of 7y first, minus the 2y, I just have to be consistent by putting the corresponding 3x first, minus the 5x. I couldn't flip-flop them with each other. So I would get the same answer if I did this, as long as I did this. Both of these would be okay. So these would be comparable. So if I did this first one, I would get 7 minus 2 would be 5y. On the bottom, 3 minus 5 would be negative 2x. Now if I did it this way, I would get a negative 5y, but then on the bottom, I would have gotten a positive 2x. So either way, I'd get that same slope of negative 5y over 2x. Now this one, they tell us the answer. So it's a little bit of an algebra problem. We have both sides of the equation. So if I did my slope formula, where I go 3a minus a, y minus y, over x minus x. Okay, careful with those negatives. Instead of trying to solve this like I did over here, they told me that the answer to this slope was negative 3. Now, this is a little bit weird. Let's clean up the left. 3a minus a would be 2a. Negative 1 minus 1 would be negative 2. But the whole thing is still equal to negative 3. It's an equation. 2 over negative 2 would reduce. So I'd really just have negative a equals negative 3, which means my final step to isolate the a would just have to get rid of that negative to see that positive a would be equal to positive 3. And you could test this out. So you could say 3 times 3 minus 3 over minus 1 should give you a negative 3. 6 minus 3 would be negative, sorry, not negative 6. 6 minus 3 would be 3. Hang on. No, I'm sorry. 3 times 3 is 9. Minus 3 is 6. Over minus 2 would be negative 3. So it checks out. So the answer for A is 3. Okay. Last down here, I've got the function and it wants me to find the average rate of change from here to there. Average rate of change is a fancy way of saying the slope. So just like these very first ones, we were finding that rate of change over time. We found the miles per hour, the feet per second. It's that same idea, except instead of starting at 0, we started at a half. So we're going from here to there for the x values. So the first thing I need to know are the corresponding x values. So I want to find h of 1/2 by plugging in the 1/2. This is why we refreshed on our function notation. Squared, okay, which is going to give us 4. And then I also need to know h of 1, the y value corresponding to this x value. This is our y's. Okay, which means I'd go 16 times 1 minus 16 times 1 squared, which should give you 0. So these are the two y values. So that means I have a point 1/2 comma 4, and I have a point 1 comma 0. Now I'm going to find that slope. So the slope is y minus y over x minus x. And again, the order is not important as long as you're consistent. Keep the x and the y together. So that's going to give me 4 over, careful with those fractions there, negative 1/2. Punch that in really carefully, use parentheses, and you should get an answer of negative 8. Okay, let's take it to some word problems, everyone's favorite. Don't panic, you got this. Okay, so this one is trying to walk us up to the bigger picture. So we've got a textbook printing company. It tells us kind of what the numbers mean, where they're coming into play, but then blah, 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 here's the equation. Those are the best kinds of word problems. We just have to interpret the equation. So it says using that equation, let's see how much we would need to pay to print 10,000 books. So is this 10,000 the cost or the books? It's of course the books, and we're looking for the cost. So I say the cost then would be found by taking 150,000, careful with those zeros, plus 4.5 times the 10,000 books I'm making. Again, be careful with those zeros, not 100,000 books, 10,000. So punching that into your calculator very carefully should give you an answer of 195,000. That should make sense considering our initial cost was the 150,000. So just kind of double check yourself there. If you got off by a 0, and got an answer of like 1,000,000 or something like that, you should be suspicious. So just kind of double check with the context. So it says now if I wanted to average that out, I just spent 195,000, but I printed 10,000 books. Let's go see what that average would be. Well, I would just take that $195,000 cost, divide it amongst the 10,000 books I got out of doing that, which of course cancels those zeros down and says that each one of those books would cost me $19.50. Now, they kind of tried to trick you here because it seems like this should lead into part C, but it's saying we've already done this. We've already printed 10,000 books. What's going to be the cost of one more? It's not $19.50. That was the average because of this really expensive startup cost. That was buying the machines, renting the factory, whatever that might be. But that's why this was pretty expensive per book. Going back to basics, the very original story that told us each time we printed a book, it cost us $4.50 per book. So we've already taken care of that startup cost. We've printed 10,000, we're just printing one more, so it's only gonna cost us another $4.50. Each one really cost $4.50, it was just that we had to overcome that really big initial startup cost. And that's why things tend to be more expensive than they seem, because there is something involved in making that get set up. Okay, here's a quick refresher of some important slope lines right here. So let's kind of see if we remember how to use these. If I needed the equation of the line given the slope and the intercept, I know that y equals mx plus b. So y equals mx plus b, just like that. Now, the slope is not x. X is not the slope. The slope is next to x, mx, okay? So x is not part of the slope, it's just next to him, mx plus b. What about if they gave us a different point in the slope? This one's not the intercept. I can't just say 3x minus 2. I need to use my point slope formula right here. Also, there is a program, if you have those programs for me on the calculator, called point slope. So let's walk through that really quick. If you go to your programs, remember this third button down right there? Scroll down, there's one in there called point slope, if you got those programs from me. PTSLOPE. PTSLOPE. Okay. Hit enter to run it. And the first thing it asks is the line undefined? Never will we deal with an undefined line. So the first thing we're always going to do is hit the number 2 to say that that's not the case. So right here, we're always going to push number 2, enter. Now I know it looks like we said 22, but we're just entering a 2. Then it says, okay, if the slope's not undefined, what is it? It told us that the slope is 3 in this problem. 3, enter. Then it says, what's the point? X first. X was also 3. And then Y was -2. Make sure to use that little negative on the bottom, not the one on the side. -2. Enter. Boom, answer. So there it is. It's kind of spread out, but that is the answer. So it says that Y equals 3x, just like we expected. There's the slope next to x, but not -2, -11. Okay, if for any reason you don't have those programs or you weren't sure how to get past that n equals undefined, here's how we do it by hand using this point slope formula. Y minus the y value equals m times x minus the x value. Distribute that parenthesis right there. Remember, this double negative turns into a positive. And then minus the 2 over, and there's that same 11. So y equals 3x minus 11. Always double check yourself that the 3 is still there, because we knew that from the beginning. It was just the 11 we weren't sure about. So just double check that that 3 is still what we expect it to be. Okay, so this one, there are words, but it's not really a word problem. Don't panic. So this one says, here's an equation. It's in standard form, not the y equals mx plus b form. Let's go in and find the intercepts. Okay, so if this was 4x plus 5y equals 7, remember that the intercepts are where they hit zeros on the x and y axis. So the x-intercept is where the y value equals 0, because if the x-intercept is along this line, it hasn't moved up or down at all. The y-intercept is where the x value is 0, because it's going to be in the middle right here where it hasn't moved left or right at all. So it seems a little backwards, but if you think about their position, it makes sense. So if I replace the letter y with a 0, then I would go 4 times x plus 5 times 0 equals 7. Well, anything times 0 is 0. So I would really just get the fraction 7/4. Sorry. Okay. If I wanted the y-intercept, I would replace the x with a 0. Again, anything times 0 is 0. This time my y is back, okay, just the x is the 0. So I'd get 5y equals 7, which means I'm going to get the fraction 7/5. Okay, they're weird little fractions, but don't stress about it. That's the answer right there. Okay, those are my 2 intercepts. And then the second part of the equation, it says find a solution other than the intercepts. That can be anything. So I'm just going to pick a random x of 1. Okay, it can be anything I want. So if I replace the letter x with the number 1, I'd get 4 times 1 plus 5y equals 7. Sorry, I can run out of room there. So this time I would have to minus that 4 over. 4 times 1 is 4. That's going to give me that 5y equals 3. And then we're just like the last time, get a fraction, but that's okay because it's just that. The y would equal 3/5. And that can be any number at all. X, Y, Z will take any number. All right. Now, it wants us to take that equation and write it in slope-intercept form. So this time I'm going to take the equation and manipulate it so that I can find the actual y equals mx plus b form. I'm going to do this here in red. So this time I'm going to take 4x plus 5y, leaving them as letters, and solve it for y. So notice that's the same steps as that last problem. I just leave it as the letters. Now, since they are letters, they're not like terms, they cannot combine. Which means in this last step, I'm just going to divide everyone by a 5. So I get that y equals -4/5 x plus 7/5. I know I've got a lot of information jam-packed into this one question. The last part of this question, it says, is this point a solution? So now with either the red equation that I've manipulated or the original, I usually go with the original. Let's see if -3 is an x and -1 is a y would give us that value of 7. 4x plus 5y, does that equal, question mark, 7? So that'd be -12 minus 5, not looking good. I don't think that's going to equal 7. So the answer is no. Okay. So all of that was for this right here. Now, this one right here is a separate problem. Sorry, I kind of ran out of room over here. I was trying to show more work than I thought I would. So this one right here, if I had this equation here, all graphed out, and I wanted to label it, to name it the y equals mx plus b equation, then I know I need both the intercept right here and a slope. Now for the slope, I just need any other pretty point. I want it right on the crosshairs. So even though I can kind of see some points here, it's close. The first one I see crossing right there on the crosshairs is here. Okay, now I'm going to count from this dot to this dot. I go down 1, 2, and I go right 1, 2, 3, 4, 5. So that means from here to there, I would go down and right. If I sign my name in the line, it's a downward slope. Down 2, right 5. So there's my M. Here is my B, my y-intercept. So the equation of this line would be y equals mx plus b. Rewrite it down here so you can see it a little better. mx plus b. The slope is a -2, so the plus b is a negative. Okay, sorry there. Hope that's not too confusing. All right, sorry, I ran out of room in there. All right, what if I wanted the equation for 2 points? Well, remember you've got these formulas right here, but there's also a super cool program in the calculator. So if you did get those programs from me, go ahead and hit the program button again. Remember it's right there in the middle. And the very first one is called a 2-point equation. Okay, so if you can find that one, it's the very best. A 2-point equation. So if you hit enter on that one, the very first one, enter to run it, and ask for the x1, which would be just this first guy right here. Just put them in whatever order you're given, 4. And then the y1, the -2, then the x2, 6, and then the y2, -1. Okay, enter, tells you the slope first, hit enter one more time, and there it is, the whole equation, all done. So it tells you that y equals 1/2 x minus 4. Super easy. Try to remember that program if you can. If you can get those from me, it's so much easier. If not, here's the steps you would have to go through. First thing, you would have to find the slope, y minus y, careful of those negatives, over x minus x. That would give me -1 over -2, which would be 1/2. Here's that 1/2 for the slope they got. Careful of those negatives. Then I would have to use my point slope formula using either one of the 2 points. I could pick either one. Y minus y equals m x minus x. Distribute that 1/2. Watch out for that double negative. 1/2 times 4 is 2. And then I would subtract this 2. Sorry, get ahead of myself. Then I would subtract this 2 over, and -2 minus another 2 is how they got that -4. All right. Here's a piecewise function, which tends to scare people, but don't be scared. Okay, it's just two little regular graphs glued together in the middle. So right here, they get glued together where the x value is 1. So the first thing I do is I kind of draw a little line here on the 1. Now I know you're going to be doing this on x, y, z, so just draw that kind of in your imagination with your eyeballs. And the first thing I'm going to do is I'm going to see where it kind of cuts off. So I'm going to plug a 1 into the top equation, and I'm going to plug a 1 into the bottom equation. Now notice on the bottom equation, there's no x. The bottom equation is 2 all the time, no matter what. So on the top here, that gives me a 0. On the bottom, it's 2, no matter what. On the top, notice that it has the bar, so it would be equal. So I would go in and put a closed dot right there on that imaginary line at x value of 1, y value of 0, 1, 0, right here, closed dot. Okay, I would also go in and put an open dot, where the x is 1 and the y is 2, because right here it says it approaches 1, but doesn't quite equal. So right here where the x is 1 and the y is 2, an open dot. Okay. Now it says it follows this pattern right here everywhere that the x's are smaller than 1, going to the left. So connecting to this closed dot right here, which is what I would put first on my XYZ graph. Put those dots first. Hang on. Let me try to fix this. Okay, put that dot first. And then I would draw the rest of this line where it's the line crossing through the intercept of -1 with a slope of 1. So notice that it all works together. Here's that slope of 1, positive 1, going down, and it does hit that same intercept, 1, -1. So I'd go in and put this little dot second. Okay. Sorry. Next, I would come up here to graph the second part of the line, again starting right here. This one had the closed dot, this one had the open dot. So I knew that it was going to have this open dot right here at 1, 2, and this one is going to be the horizontal line, y equals 2 for the rest of forever. No matter what x I pick, the y is always 2. So it stretches out right here, going straight across. So I would put this dot third, and then any dot down here as the fourth dot to continue this straight horizontal line. Okay, so the first dot here on the closed, second dot to complete that line, third dot open, fourth dot right here. Okay, now on XYZ, you're going to do these 4 dots just like I described, but you'll do them using your line tool. So you do 1 dot, 2 dot, it makes a line. 3 dot, 4 dot, it makes the line. And then after you make your 2 lines, then you go back and there's actually the dot tools on XYZ. So down here you've got your options. So the first dots you make using that line tool looks like this. Okay. Then after you complete your line tool, you'll go and grab those dot tools. There's an open dot tool and a closed dot tool. And you'll go back and finish this off by putting that closed dot here and then the open dot here. Okay, so that'll be your 5th and 6th steps. Okay, so you'll need to make the lines and the dots on the end. So it's a little bit tricky. Please let me know if you have any trouble with that. Okay, and that finishes us off. Sorry for the little bit of kind of jam-packed information in there. Let me know if you have any questions.